Good morning, everyone. My name is Kitika Narnolia, and today we are going to learn about the topic how to analyze big data. In this session, I'll take you through what big data actually means, why it has become such an essential part of today's world, and most importantly, the step by step process of analyzing it to extract useful insights. In the modern digital era, data is being produced at an unimaginable speed. From our smartphones, social media posts, online shopping, sensors, financial transactions, everything is generating data. But just having data is not enough. We need to analyze it properly to gain meaningful and actionable insights. That's where big data analysis comes into the picture. Now, let's begin by understanding what big data actually is. Big data refers to extremely large, complex data sets that cannot be easily managed, stored, or analyzed using traditional databases or software. In simpler words, big data means a lot of data that grows too fast and comes in too many forms. This data is being generated from multiple sources every second: social media, online banking, e commerce platforms, IoT sensors, healthcare devices, and more. Why is big data important? Because it helps organizations make better and faster decisions. For example, in healthcare, big data helps doctor predict diseases earlier and personalize treatment. In finance, it helps detect fraudulent transactions. In retail, it helps companies understand customer behavior and offer personalized deals. In technology, it supports AI and machine learning systems to make accurate predictions. In short, big data acts as the foundation of data driven decision making across all industries today. Now, big data is commonly described using the three V's: volume, velocity, variety. Volume refers to the massive amount of data generated every second. For example, Facebook users upload around 300 million photos daily, and YouTube users watch billions of videos every day. Traditional tools simply cannot handle such large volumes. Velocity means the speed at which data is created and processed. Think about stock market updates, online payments, or live GPS tracking. The data is flowing continuously and needs to be processed in real time. Variety represents the different types of formats of data. Some data is structured, some is semi structured, and some is unstructured. Now that we know that what big data is, let's understand how it is analyzed. Big data analysis usually follows a six-step structured framework which helps in converting raw data into meaningful information. The six steps are: define objectives, identify identify what exactly you want to achieve, collect data, gather the right data from reliable resources, then it's store and organize data efficiently, then remove errors and make data ready for analysis, apply suitable analysis techniques to draw insights, and then it presents the results in understandable and visual format. Each phase is essential, and skipping any of them can reduce the accuracy and reliability of the final conclusions. The first and most important step is defining the objective. Before you begin analyzing anything, you must know what question you're trying to answer. Without a clear goal, the analysis can easily lose direction. To define objects, you need to identify the specific problem to solve, set key performance indicators or success metrics, understand stakeholder expectations, what your team, manager, or client expects from the analysis, set realistic timelines, and decide what resources you'll need. For example, a company may set an objective like analyze customer behavior to create personalized marketing campaigns and increase conversion rates by 25% within 6 months. The key metrics here could include conversion rate, customer engagement, and customer lifetime value. When objectives are clear, the rest of the process becomes much more focused and effective. Now, once the goal is set, the next step is data collection. Data can come from multiple sources: social media platforms, IoT devices and sensors, business transactions, third party APIs. While collecting, it's also important to understand type of data. Structured data is well organized in rows and columns like spreadsheets. Semi-structured data includes flexible formats such as JSON and XML. Unstructured data is text, images, audios, or videos and needs advanced tool for processing. Once we have the data, we must decide where and how to store it. Because of its huge volume, storing big data is not as simple as saving it in an Excel file. Some modern storage technologies include Hadoop. It's an open source framework that allows distributed processing across multiple computers. NoSQL databases like MongoDB, these handle unstructured or semi-structured data with flexible schemas. Cloud storage. Platforms like AWS, Google Cloud, and Azure offer scalable and pay-as-you-go storage options. Data lakes. These store raw data in its original form until needed. Data warehouses. These are unstructured and optimized for analysis and querying. Now, data cleaning and preparation. This is one of the most time consuming yet critical steps. In fact, almost 60 to 80% of the total analysis is spent on cleaning data. If your data is messy, your results will be wrong, no matter how advanced your analysis is. Data cleaning involves removing errors and duplicates to eliminate corrupted or repeated entries, standardizing formats, making sure units, dates, and text formats are consistent, handling missing values, using imputation or removing incomplete rows, using ETL pipelines. ETL stands for extract, transform, and load. These pipelines automate the cleaning and transformation process using tools like Python, R. R. Now comes the core step, analysis. There are different analytical approaches. Descriptive, descriptive analysis answers what happened. Diagnostic analysis answers why did it happen. Predictive analysis answers what will happen next. Prescriptive analysis answers what should we do. Together, these methods helps organization move from simple data observation to actual data-driven decisions. Now, let's look at some of the most commonly used methods in big data analytics. First is data mining, finding patterns and hidden relationships in large data sets. Machine learning and AI, using algorithms like for classification, clustering, and prediction. Regression analysis, understanding what relationships between dependent and independent variables. Time series analysis, tracking trends and forecasting based on time-based data. Natural language processing, analyzing human language like chat or social media posts. Sentiment and social network analysis, studying opinion on social influence online. These techniques turn raw numbers into meaningful insights that can guide business strategy.